Continuing on with the creation of our screw thread from the previous video, let's select our object and then press the W key in order to engage the Move tool. Holding down the Shift key, let's right click in the viewport to bring up our snap options, turn off grid points, and then Shift right click again so as to enable vertex snapping. Whilst in the Snap Squad menu, we need to make sure that the Enable Axis Constraints in Snap option is turned on, because we're going to want to constrain our moves here to just the vertical axes. Jumping into our left view then, let's maximize using the Alt and W keys. Press S to enable snapping, and then left click on the Move Gizmo's up axis in order to constrain our moves in this viewport to just up and down. If we hover our cursor over this bottom vertex until we see the cursor change to a move icon, now we can hold down the Shift key and then left click and drag until our snapping locks our bottom and top vertices to the same point in 3D space. What we need to do now, of course, is decide, well, how tall we actually want our screw to be. In this instance, I am probably going to go a bit over the top, as we can always delete faces or vertices if we end up with too many of them. Let's go with a value of 6 and worry about exactly how many of them we will eventually need a little later on. If we come back to our perspective view by pressing the Alt and W keys now, and then press F4 to show edged faces, we can select all of the objects that we've created, turn their wire color to black from the command panel, and then left click in the viewport in order to deselect everything. We could also, of course, use the hotkeys of Ctrl+D. What we have now is this nicely angled spiral running up and down our geometry. Obviously, we still need to connect them all together, and so let's select the bottom object, and then right-click and convert to an editable poly. In either the command panel or from up on the ribbon, we need to click the Attach button, and then simply click on each of the components in turn in order to add them all to a single mesh. Now, whilst we obviously have all of these geometry pieces stacked on top of one another and have them all sitting inside the same mesh container, the vertices of the various elements here are not in fact welded together. To fix that, let's press the 1 key so as to enable vertex subobject mode, press Ctrl+A to select all of the vertices in the mesh, and then from inside the vertices panel up on the ribbon, hold down the Shift key and click the weld option. Now, I prefer to have the caddy open whilst performing these types of weld operations, as it gives us this nice before and after vertex count, meaning we can easily tell if the tolerance we are using is actually welding all of our vertices together or not. To make certain that it is in fact happening, we can easily increase the tolerance, which clearly isn't making any difference at all here, and so we are definitely welding all of the vertices that we want. With that done, we can hit OK and come out of subobject mode. So, with the spiraling geometry nicely in place, what we are going to do in our next video is actually extrude the thread, and then just make certain that the topology on it is nice and clean.